Alright, so today we're going to talk about perpendicular lines. Our objective is to prove and apply theorems about perpendicular lines. So remember that perpendicular lines, we use this symbol to show that lines are perpendicular. And perpendicular means two lines that intersect at a 90-degree angle. So if I'm looking at a perpendicular bisector of a segment, it's a line perpendicular to a segment's midpoint. So if I have this segment AB and C is the midpoint, then the perpendicular bisector would be a line that goes straight through it at a 90-degree angle. That would be my perpendicular bisector. So in this case, line CD is the perpendicular bisector. The next one, the shortest distance from a point to a line is a line from that point perpendicular to the line. So here's my point and a line. The shortest distance to get from this point to this line is going straight down at a 90-degree angle. That's where I find my shortest distance. So there are three different theorems that we're talking about today. The first theorem says if two intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. So basically kind of what that looks like is if I have two lines that are intersecting, and I know that two lines intersecting form a linear pair because this one plus this one is 180 degrees. So if these two angles are congruent to each other, then I know that these lines are perpendicular. They form 90-degree angles. So these angles would be 90 degrees. The next theorem says, is a perpendicular transversal theorem. It says in a plane, if a transversal is perpendicular to one or two parallel lines, then it's perpendicular to the other line. So in this case, if I have a set of parallel lines, and then this is my this is my transversal. If it's perpendicular to the top line, it's got to be perpendicular to the bottom line. And the last one, if two coplanar lines are perpendicular to the same line, then the two lines are parallel. So if I have two lines, and I know that they're both perpendicular to this line, that means these lines are parallel. Okay? So let's look at this proof. It says given that RS, these two lines are parallel, and given that angle 1 is congruent to angle 2, I need to prove that R and T are perpendicular. Well, if I look at this theorem up here, it says if I have two intersecting lines and the linear pairs are congruent, so if 1 and 3 are congruent, then these lines are perpendicular. So it looks like it'd be a good way to prove this. So let's see. I don't know anything about 1 and 3 yet, but I know that 1 is congruent to 2. Well, let's look at 2 and 3. Are those two angles congruent? Yes, angle 2 is congruent to angle 3 because they are corresponding angles. So we use the corresponding angle postulate to say that angle 2 and angle 3 are congruent. So from there, I can say that angle 1 is congruent to angle 3 because of the transitive POC. 1 to 2 and then 2 to 3, so 1 to 3. So now that I know that angle 1 and 3 are congruent, I also know that angle 1 and angle 3 are linear pairs. And we know that because of the definition of a linear pair. If two angles form a straight line, then they're a linear pair. So then lastly, I can say, number 6, that R is perpendicular to T because of this theorem up here that says two intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. So this theorem doesn't have a name, but we'll just write this down when we use this theorem, okay? Alright, let's go to the next page. So now let's look at doing some solving. So I know that this is a 90-degree angle, so this also has to be a 90-degree angle, and so does this, and so does this. So I know that 19x plus 4y equals 90, and I know that 22x plus 2y equals 90. So I'm not used to having x and y's in the same equation, or at least y'all usually aren't. But we did this in Algebra 1, where we have two equations, which is a system of equations, and we solved them by substitution or by elimination method. So what I'm going to do is I'm going to solve this system of equations by the elimination method. I'm going to take this second equation and multiply it times 2. And I'm going to keep the top equation the same. So now what I've done is I've created my y's that have the same value in front. They both have a 4. So now I'm going to subtract these two equations from each other. So 19 minus 44 gives me negative 25x. 4 minus 4 gives me no y's. And 90 minus 180 gives me negative 90. So when I finish solving, I end up with x equals 3.6. So now that I have my x value, I can plug it into either equation and find my y value. So I'm going to use the top one. 19 times 3.6 plus 4y equals 90. So when I solve, I get 68.4 plus 4y equals 90. And then 4y equals 21.6. So y equals 5.4. So I have an x value and I have a y value. And I still want to check to make sure my answers are right because they seem kind of funky. So I know if I plug in x, 3.6 for x, and 5.4 for y, I should have this equation equal 90 and this equation equal 90. So let's see. 22 times 3.6 plus 2 times 5.4. Type that in your calculator and you should get 90. And then 19 times 3.6 plus 4 times 5.4. You type that in, you should get 90 as well. So my x would be 3.6 and my y would be 5.4. Alright, so the last two examples talk about the shortest distance from a point to a line. So it says name the shortest segment from P to line AC. Well, I know the shortest segment has to be perpendicular. So in this case, segment PB is the shortest segment. From P to AC. So then it says write and solve an inequality for x. Well, if this is the shortest segment, I know that this segment AP has to be longer than it. So I know that x plus 3 has to be greater than 5. So then when I solve for x, I know that x has to be greater than 2. Alright, last one. So it says name the shortest segment from A to BC. Well, it has to be a 90-degree angle, so in this case, segment AB is the shortest segment from A to line BC. So it says write and solve an inequality for x. Well, since this is the shortest segment, I know that 12 has to be greater than x minus 5. So x minus 5 has to be less than 12. So now when I go to solve for x, I get x is less than 17. That is all.